Hello friends, welcome to the Vicky Notes tutorial. This tutorial will help you to learn the concept of operating system for GATE, UGC-NET PSU and university exam. Please friends press the like button and subscribe my channel. Resource Allocation Graph. Resource Allocation Graph (RAG) is a graph that represents the state of a system pictorially. It gives complete information about the state of a system such as how many processes exist in the system, how many instances of each resource type exist, how many instances of each resource type are allocated, how many instances of each resource type are still available, how many instances of each resource type are held by each process, how many instances of each resource type does each process need for execution. Components of RAG. There are two major components of a resource allocation graph: vertices, edges. Vertices. There are following types of vertices in a resource allocation graph: process vertices, resource vertices, process vertices. Process vertices represent the processes. They are drawn as a circle by mentioning the name of process inside the circle. Resource vertices. Resource vertices represent the resources, depending on the number of instances that exists in the system. Resource vertices may be single instance or multiple instance. They are drawn as a rectangle by mentioning the dots inside the rectangle. The number of dots inside the rectangle indicates the number of instances of that resource existing in the system. Edges. There are two types of edges in a resource allocation graph: assign edges, request edges. Assign edges. Assign edges represent the assignment of resources to the processes. They are drawn as an arrow where the head of the arrow points to the process and tail of the process points to the instance of the resource. Request edges. Request edges represent the waiting state of processes for the resources. They are drawn as an arrow where the head of the arrow points to the instance of the resource and tail of the process points to the process. If a process requires n instances of a resource type, then n assign edges will be drawn. Example of RAG. The following diagram represents a resource allocation graph. It gives the following information. There exist three processes in the system, namely P1, P2 and P3. There exist two resources in the system, namely R1 and R2. There exists a single instance of resource R1 and two instances of resource R2. Process P1 holds one instance of resource R1 and is waiting for an instance of resource R2. Process P2 holds one instance of resource R2 and is waiting for an instance of resource R1. Process P3 holds one instance of resource R2 and is not waiting for anything. Deadlock detection. Using resource allocation graph, it can be easily detected whether system is in a deadlock state or not. The rules are: Rule 1. In a resource allocation graph, where all the resources are single instance, if a cycle is being formed, then system is in a deadlock state. If no cycle is being formed, then system is not in a deadlock state. Rule 2. in a resource allocation graph where all the resources are not single instance. If a cycle is being formed. Thank you so much friends for watching my video lectures.